Circle Geometry, Rider 6. Here we go again with the reminder. Circle Geometry Strategies, part of the series at that address. And from that video we have know your theorems. Don't wait for the geometry to come to you. Ask questions. Start with what you're finding or proving. Don't just draw on everything equal you can find in the diagram. It will just confuse you. If proving two angles equal, take one and find what it is equal to, and then see if the other one's equal or combines in the same way. If proving something about lines or shapes, ask what if it is so. Proving parallel lines, what if they are so? Oh, these two angles would have to be equal. Let's try to prove these angles equal. Proving a cyclic quad, well, is the exterior angle equal to the interior opposite angle? So rider number 6. We have two tangents, tangent DE there, and we have tangent DB there. We're first proving parallel lines. So that's about lines. So we're going to say, what if it is so? And notice there the parallel lines marked in there in blue. Well, the alternate angles would have to be equal to one another. So I say to you, prove this then. So we're going to prove that D1 equals F1 in order to get the lines parallel. So go to the angles and take one of them. What is D1 equal to? There's your big hint in pink. You're in the pink there. D1 is equal to B2. Tan chord. There we are. So now our logical question, is B2 equal to F1? And there we're in the purple now. Yes, tan chord as well. So therefore we have the very angles we're trying to prove equal to one another completed. So our first part of the proof. D1 equals B2, tan chord. But B2 equals F1, tan chord. And therefore D1 equals F1. Now we haven't finished yet. That was part of our what if it is so. Now we have to go one step further and say, now we have the alternate angles equal. So we can say, well, therefore the lines are parallel. And the reason alternate angles equal, you might want to say converse alternate angles, parallel lines, but I'm mathematically lazy, so I'll always go for the shorter references with as much abbreviation as possible. Next part of the proof. We have to prove that ED is a tangent to circle EAG. So there we are. I've drawn the situation there and it's easier to see. What if it is so? So there's a circle going through those 3 points there. What if it is a tangent to the circle through those 3 points? Well, E1 would have to equal G1 by tan chord. So, prove this. So we're now going to prove the blues are equal to one another in order to get it to be a tangent. How do we do that? We take one of them. What is E1 equal to? There's my hint in the pink. E1 equals B3. Alternate angles and the lines are parallel. Now my obvious next question, I'm trying to get E1 equal to G1. I've got E1 equal to B3. So I'm going to say, well, is B3 equal to G1? And there's the green hint for you. We have a cyclic quadrilateral and there's the exterior angle. Yes, exterior angle, cyclic quad. So we have E1 equal to B3, B3 equal to G1. So by axiomatically, E1 equals G1. Our proof, E1 equals B3, alternate angles, parallel lines. B3 equals G1, B3 equals G1, exterior angle, cyclic quad. Therefore E1 equals G1. And This is the converse of tan chord, so therefore ED is tangent to circle EAG, converse tan chord.